Well, Dr. Bikman, or Ben, it's great to talk to you. Thank you so much for joining me on the Happy Habit podcast. We like to talk about health and well-being here. And can I congratulate you on your book, Why We Get Sick, The Hidden Epidemic at the Root of Most Chronic Disease and How to Fight It. And a great read, lots of value in there. We'll dip into that during the course of this discussion. You've written this book, though, because you wanted to shine light on the origins of metabolic disease because you believed it hasn't really been appreciated thus far.
Right. Yeah. Thanks again for the invitation to join you. Yeah. The primary purpose for the book was to help shift the focus, if you will. It wasn't so much that I was worried not enough people were talking about metabolic health. That's certainly been a very active, vibrant discussion, at least in the popular culture, and to a degree, certainly in the medical space. My concern was that we were simply looking at it incorrectly, whereas the classic paradigm on metabolic health has had us focusing almost exclusively on the molecule glucose or blood sugar. My contention is that there is another one that we've been missing that many consider to be the sidekick, that they think blood sugar is the hero or the villain of the story. That's the one we have to focus on. And any mention of insulin, this hormone in the blood, is almost an afterthought, where very commonly, even with conventionally trained clinicians, insulin is discussed purely in terms of what it can do to lowering blood sugar levels. And my entire argument, and certainly the justification for the book, is that insulin is in fact the main character in the story that we're trying to tell about metabolic health and the dangers of poor metabolic health, which is a global phenomenon. Insulin is the metric that matters. So whereas our classical view has had a glucose-centric paradigm, it's glucose through which we see metabolic health. That's what we measure all the time, whether it's fasting glucose, whether it's A1C, whether it's wearing a continuous glucose monitor. My thought is, yes, those are valuable, particularly a glucose monitor, but they have much less value if we don't look at it firstly through the lens of insulin. So we need an insulin-centric paradigm. And then once our view shifts to looking at insulin as the marker, it becomes, there's this expression, the canary in the coal mine, which is this kind of early indicator of a problem. Insulin is a much earlier indicator of this descent into metabolic mayhem than glucose is. For example, an individual who's moving towards type 2 diabetes, which is like the penultimate evidence of metabolic disruption, while everyone's looking at the glucose, it's possible that a person is going through their 20s and their 30s and their early 40s and their glucose is staying totally normal. And so the clinician says, oh, you're fine. There's no hint of a problem. At the same time, they're now on a blood pressure medication. Maybe they're on an erectile dysfunction medication in the case of a guy, or another fertility medication in the case of a woman for her PCOS, but not thinking that there's any metabolic underpinning because glucose is staying normal. However, if that view had gotten larger or even shifted to encompass insulin, while the glucose has been staying normal, the insulin has been waging this silent war, silent because no one's thinking it's relevant here, but insulin levels are going higher and higher and higher every year in an effort to keep the glucose in check. And this, of course, would be evident. We would see this if we measured it. And now the whole conversation changes where, especially if someone's very informed, they would say, well, your glucose is normal, but gosh, you need a lot of insulin to keep it there. You have insulin resistance, as many people do, and this is what's contributing to your infertility or your fatty liver disease or your hypertension. So let's improve your insulin resistance rather than give you a specific medication for this specific disorder. So to kind of wrap all this up, as I've elaborated maybe too much, insulin is the marker we should focus on. Not only does it help us detect problems sooner, but it also helps us treat the problems better. Because if a treatment is aiming to improve a chronic disease, certainly those that have a metabolic foundation, as most chronic diseases do, if it fails to address the insulin, you're only treating a symptom and you're failing to actually solve the problem.
Has glucose been a distraction then in this discussion about the body's metabolism and over the decades? Has it been a distraction because when people think glucose, people think spiking in glucose levels because of, let's say, dietary sugar intake? Is it more, is it easier to understand the glucose's effects on the body's imbalance or balance than it is to understand the role that insulin plays on the body's metabolism?
Mm-hmm. Yeah, that's a really good point. To answer the last part of the question first, yes, it is much easier to appreciate what glucose is doing. So I have to give glucose credit, and even excuse the people who continue to focus on glucose, because it is so much easier to measure glucose. So that's the scientific advantage that glucose has in its favor, explaining why why we look at glucose and why we continue to look at glucose while ignoring insulin, because glucose is so easy to measure. Indeed, it's so easy that a person can wear a little device clicked to the back of their arm or their belly and know what their glucose levels are at literally any second of the day if they want. There's no technology that comes even close to allowing the same convenience and clarity in measuring insulin. We are a decade away at best from being able to do that. At the same time, while it is scientifically easier to measure glucose, providing a justification for, or an excuse rather, for continuing to look at glucose, we also have this historic perspective, which is classically the only, even nowadays, the main symptom of diabetes is the high production of urine. That's what diabetes means. The word diabetes means high urine production or polyuria. So the person is producing an incredible volume of urine every day. That is a direct product of really high glucose levels. And that high glucose gets into the urine, which pulls more water, which makes more urine production. And this is why the earliest observations of glucose would refer to the urine as being honeyed. Not because it tasted sweet. It doesn't. Glucose doesn't taste sweet. It's that flies would come to the urine as if they were coming to honey, because the flies would come and be eating up all of the sugar, or the glucose, to be more precise, within the urine. And so we have this historic excuse and justification for looking at glucose, in that the main symptom was a result of the high blood sugar. And two, we have a scientific excuse, which is that glucose is just a lot easier to measure. However, now that we can measure insulin so readily from any blood test we get, and the cost and the convenience of measuring insulin has come down dramatically and continues to improve, I think that those excuses are starting to wear a little thin, that we can't rely on the way we did it before, even as justifiable as it might have been. We need to start changing the conversation. So that helps us understand why it might have been that way. And none of this is to say that glucose is benign. As much as I am an enormous advocate that we need to shift the focus from glucose to insulin, high glucose does have complications. And I think the more widespread continuous glucose monitors become, I think the more value glucose has. And so, maybe to say that another way, while I think a fasting blood glucose measurement is of very limited value, a dynamic insulin measurement, one that is really letting the person see what their glucose is doing all the time, has much more value, because they go and eat that meal and they can see what happens to their glucose and how long it takes to come back down to normal. That's much more valuable than just waking up after a 12-hour fast and getting a blood draw.
But in the context of what you said about us being distracted by glucose and not focusing more so on insulin, are glucose monitors only, and the results we get from them, only part of the picture, of the discussion?
Yes, yeah. My thought is that the wearing of a continuous glucose monitor should be in and of itself an early indicator. Whereas fasting glucose levels may be normal in a person, their dynamic glucose responses to a carbohydrate load might not be. But even still, so as much as I think a dynamic glucose has value, it still pales in comparison to an insulin measurement.
Well, we're talking about insulin. Can you define for us what exactly insulin resistance is?
Yeah, I'd be happy to. Yeah, so insulin is a hormone that is made from the beta cells of the pancreas. That's its origins. And we all have insulin, we all have beta cells, except for people with type 1 diabetes. In type 1 diabetes, those have been destroyed through an autoimmune disease. Now, insulin resistance is a two-sided problem, or there are two fundamental pillars to this, or it's like a coin that has two sides. This coin that I'm holding is insulin resistance. And on one side of the coin is what we think of when we think of the word insulin resistance, which is to say that some parts of the body, not all of the body, some parts of the body fail to respond to the hormone insulin as well as they used to. So once upon a time, insulin would come to the door of a cell, knock on that door, and then the cell would have a very robust response. That response becomes diminished in some cells. That is insulin resistance. And I am emphasizing some just to put a fine point on the fact that some cells of the body are as responsive to insulin as they ever were. Insulin comes and knocks on the door, and the cell responds exactly like they should. So that's why I'm emphasizing that even what we call insulin resistance is not a universal phenomenon affecting every cell of the body equally. Some cells become insulin resistant, some cells are fine. Now, however, we flip the coin over because there is another part of insulin resistance that is very often overlooked, which is hyperinsulinemia, or high blood insulin levels. There can be no such thing as insulin resistance without an accompanying hyperinsulinemia. These two things will always come together in a chronic state. Now, that becomes a particular problem in light of how I described what insulin resistance actually is. So where some cells weren't responding to insulin knocking on the door very well, if we now have a big angry mob of insulin pounding on the door because insulin levels are higher, we're maybe able to get the cell to respond like it should have. It just took a lot more insulin to do it. That's in and of itself fine, relatively. However, there are other cells that are responding perfectly well to insulin. And now that there's an angry mob pounding on their doors too, they're doing too much. They are overstimulated. Whatever insulin was telling them to do is happening way more than it ought to in a healthy state. The combination of all of these variables is what plays into insulin resistance. And to varying degrees, whether it's the insulin resistance part of it or whether it's the hyperinsulinemia part of it, this is how insulin resistance as a whole affects virtually every tissue of the body, and thus explains how insulin resistance contributes to virtually every chronic disease, whether it's heart disease or Alzheimer's or fatty liver or infertility or muscle wasting. All of these problems and more are a direct consequence of insulin resistance.
What many people probably don't realize listening to this podcast is that they are deriving their energy from burning fat and burning glucose. Can you tell us about this hybrid fuel burning balancing act, for want of a better word, that is key to our metabolism?
Yeah, that's a really wonderful question, and I hope people can really resonate with this. So, just for the sake of really establishing a rigorous foundation in this answer, there are numerous fuels the body can use. You'd mentioned the main ones, and I'll come back to them in just a moment, of course, fats and glucose. Those are the main fuels the body uses. And to lower degrees, the body also uses ketones as a fuel, and even lactate. You know, the lactate that we all think we should be afraid of that comes from working muscle, that is very much a fuel that is used by any cell with mitochondria, including muscle themselves. So those are kind of the main fuels, if you will. Now, although albeit with the last two, ketones and then much less lactate being, lower level fuels, depending on the state of the person, ketones can account for a much higher rate of fuel use if the body needs it, or they're available. So fat and glucose are the main fuels the body has. And so, as you cited, the metabolic engine in the body is a bit of a hybrid where it can shift between glucose and fats as the main fuels for the body as a whole. And this is one of the ways that I define metabolic health. People will talk about metabolic health very often, and it's become this kind of vague, ambiguous term without a clear definition. I, on one hand, appreciate that because there might be numerous ways to define metabolic health. And indeed, I have a couple myself that I use. One is this concept of metabolic flexibility. When you eat a typical meal, typical being a meal that has all of the macronutrients, fats, proteins, and carbs, especially the carbs, will result in an increase in insulin. And as insulin goes, so too does fuel use. If insulin is high, then the body will shift to glucose burning as a primary source of fuel. So most of the body's energy after we eat a meal is coming from glucose burning. And that's because insulin has told the body to do so. However, give the body several hours, 6 hours later, all of the blood sugars come to normal. Insulin has come down. Now, with insulin being low, the body shifts its hybrid metabolic engine to rely more on fats as a fuel. So now we're primarily fat burning rather than sugar burning or glucose burning. However, so this is metabolic flexibility. When we eat, we burn sugar. When we don't eat, we burn fat. And that is entirely predicated on insulin being high or low, respectively, in the fed or the fasted state. However, there are people, indeed many people, who have poor metabolic health. And this is reflected in a state called metabolic inflexibility. And this is, as people might imagine, a body which is stuck in sugar burning mode, that when they eat, they're burning sugar, just like we would expect. However, give them 6, 8, 12 hours later, they're still kind of burning more sugar than fat when they should have shifted over to being almost entirely fat burning. But that's because insulin. We need not go any further than insulin, once again, invoking this real key mediator here. Because in this body, which has insulin resistance, the insulin levels are always too high. So even hours after they've eaten, insulin should have come down hours ago. It's still high. And if insulin is still high, the body continues to burn blood sugar rather than shifting over to burning fat. And so in other words, they're stuck. The metabolic machinery is stuck. The gears are jammed and they can't switch over to the other fuel, or the valve is jammed and now they're stuck sugar burning. That's metabolic inflexibility, which is, as I hopefully conveyed, simply another manifestation of insulin resistance.
And is that then exacerbated by the foods that people are eating?
Right. Yes. Completely. And that's because, to shift the conversation a little bit, it's because of how insulin resistance starts. Insulin resistance has what I consider, as an insulin resistance scientist, there are 3 primary causes, each independent of the other, that is capable of causing insulin resistance in cells throughout the body. One of them is stress, which is to say that the stress hormones, namely cortisol and epinephrine or adrenaline, when they are up, they will make the body insulin resistant. So stress is an independent cause, albeit I would say one that is more modest in most people, but it's relevant. The second one is inflammation. Anytime the body's immune systems are turned on, the body will become demonstrably more insulin resistant than it was before the immune system was turned on. So inflammation, and people can notice this if they're starting to feel a little sick, they got a sore throat or a runny nose, and if they're wearing a continuous glucose monitor, they may find that their glucose levels are way higher than normal and much more variable. So then the third and final, and what I consider to be the most relevant of all causes of insulin resistance, which gets us to diet, neither of the other two really impact diet or impacted by diet, and that is chronically elevated insulin. Now, the astute listener, Matthew, is of course thinking, wait a minute, Ben, you just got done describing how elevated insulin is a part of insulin resistance. Now you're saying that it's a cause. Yes, it is. Elevated insulin is both a cause and a consequence of insulin resistance, which starts to feed forward. We get a positive feedback. But this is what brings us to diet in particular, because if you look at the 3 macronutrients, they don't all have the same effect on insulin levels. Fat, for example, has no effect. A person could go eat a dab of butter and we could measure their glucose, or measure their insulin levels, and we've done this in my lab. We'll publish some of this soon. There will be no insulin response whatsoever. It's a flat line. If someone eats pure protein, depending on the person, there may be an insulin effect, or there might not be. Even if there is an effect, it's not enormous. It's a pretty modest one. Third and final, if a person eats pure glucose, pure carbohydrate, the closest thing would be like bread, for example, then there is or sugar, then there's an enormous increase in insulin. Insulin will go up 10 times, even in a healthy person, and it'll take about 2 hours to come back to normal, between 2 to 3 hours before it comes back down. Now, that's for an insulin sensitive person. Insulin goes up 10 times, comes down hopefully in about 2 hours. In an insulin resistant person, if they eat that same amount of glucose or the same amount of refined starch or sugar, now the glucose could go up 20 times, and it may take 4 hours for it to come back down to normal. Now, that all in and of itself is a problem. But when we look at it within the span of an entire day, the problem really becomes apparent, because the average individual is not only eating roughly 70% of their calories from carbohydrates, and nowadays that means mostly refined starches and sugars, but they're also eating every 2 to 3 hours. And so they wake up, insulin has been coming down overnight, slowly, slowly, slowly. Hopefully by the time they wake up, insulin is at a nice fasting level. However, the average breakfast nowadays is one that consists of an enormous amount of sugar and refined starches. So they spike their insulin up 10 to 20 times. And then a couple hours later, it starts to come down, depending on the insulin sensitivity of the person. And we live in a culture where now the person has to have a mid-morning snack, which is once again going to be some kind of sugary coffee or some other sugary type of snack. And now we have a pattern for the rest of the day where every 2 or so hours, the person eats or drinks something. I mean, many times nowadays they're sipping on a sugary soda or something all day. And so the average individual is living every waking moment in a state of elevated insulin. And the more insulin there is in the body, the more the body starts to become resistant to it. And that is, as it might not sound intuitive, it might sound a little confusing, but I submit there's something deeply reasonable about it. Indeed, this is reflective of a fundamental biological principle, which is too much of something will result in a resistance to that something. If a stimulus is incessant, just for the cell to survive, it will become deaf to it. I mean, this is like standing next to the loudspeakers at a rock concert all the time. You're going to become deaf because too much sound results in a resistance to the sound, just like too much insulin results in a resistance to the insulin. So this is what brings us to really focus on diet, and why I do, as much as medications are all the popularity these days. Only just give a prescription for a medication. You can never solve the problem. This is why people will say, conventionally trained clinicians will say that type 2 diabetes, which is just insulin resistance that's gotten really bad, is an irreversible disease. They will say this. Type 2 diabetes is an irreversible disease. And that is because if you take this metabolic problem of insulin resistance and try to solve it with a medication, you will never get off the medication. You may bring the person's numbers into an acceptable range. You may bring their glucose into a range that you want, but this isn't a glucose problem. It's an insulin resistance problem. And so the question must be, are you improving the insulin resistance? But even with the very few medications that do improve insulin resistance, the side effects are, I would say, pretty negative, but you also can't stop the medication. That's why they'll say it's irreversible, because while the medication may be managing it based on what the clinician wants to see, you're never actually solving the problem. Insulin resistance is a disease of spiking your insulin too often. So the food we eat is the culprit or the cure. It ends up being the culprit in most instances because of diets that are constituted by almost entirely refined starches and sugars eaten every 2 to 3 hours. If we can get off that crazy roller coaster of a carbohydrate obsession and never letting the body take a break, and rather focus on proteins and fats and have substantial gaps between when we eat, now all of a sudden we are directly curing the insulin resistance.
What's the relationship between insulin resistance and hypertension?
Hypertension? Yeah. Yes, hypertension matters because it's one of the leading risk factors for heart disease. So it's prudent of us to focus on hypertension. The mechanisms are actually myriad. insulin resistance, I would argue, is the leading cause of hypertension. And in fact, it's one of the reasons why when I ask people to try to understand the scope of the insulin resistance problem and, ask them a series of questions, one of the first questions I will ask is, do you have high blood pressure? Because if a person says yes, the conversation, we almost need not go any further, just because insulin resistance is so commonly the cause of of hypertension. And as I noted, there are myriad mechanisms, just to cite a few of them. One being that in insulin resistance, in the elevated insulin, when insulin is high, it prevents the body from dumping salt from the blood. Normally, if the salt levels start to go up a little high, that's no problem. The kidneys will simply dump the salt into the urine and then resolve that pressure, because where salt goes, water wants to go. So if a person has a lot of salt in their blood, they'll have more water in their blood. And if they have more water in their blood, they'll have a higher blood volume. And if they have a higher blood volume, they have a higher pressure. It's basically like we're forcing more water into the hose, if we're thinking of a garden hose. So there's a lot more pressure. And this would be evident as the water shooting out a lot further. So that's one mechanism, and a big one indeed, where insulin resistance forces the body to retain salt when it would normally just dump it very easily. Second, when insulin is elevated, it activates the sympathetic nervous system. And so the sympathetic nervous system is the fight or flight response that we always think of when we start to feel amped up, we're anxious, we're getting a little hot and sweaty, and our heart is beating harder and faster. And it's that last part that really matters in the case of hypertension. When the sympathetic nervous system is turned on, not only will the heart beat harder and faster, which is increasing pressure, but our blood vessels throughout our body start to constrict. And that means pressure goes up even higher if we're narrowing the blood vessel. Now, that serves a purpose, because if we were running away from a threat, having a higher blood pressure actually means the blood is moving much faster through the body, and that helps move oxygen and nutrients around. So it's good if we're trying to run away from something. However, if we are trying to just rest, like at the end of a day, for example, and we've accidentally spiked if we very deliberately spiked our glucose because we were indulging in a sugary snack, now we're going to bed with a high insulin level, which is activating our sympathetic nervous system, making us feel anxious. And we're lying there in bed wondering, why am I so anxious? Well, you're not actually anxious. You just spiked your insulin. So another mechanism whereby insulin resistance promotes hypertension, and maybe I'll just mention one more of several more, which is what happens to nitric oxide. So the medication Viagra, for example, is a medication that works to improve erectile dysfunction simply because it increases the levels of nitric oxide in the blood vessels, and nitric oxide will dilate blood vessels. So this is one of the reasons why even Viagra can be used for a blood pressure lowering medication. It just increases blood flow by increasing nitric oxide. Now, to put Viagra aside now, because explaining insulin resistance has nothing to really do with Viagra, but it has a lot to do with nitric oxide. Normally, when insulin is flowing through the blood, it will interact with the blood vessel wall, what we call the endothelium, and it will increase the levels of nitric oxide in the endothelium, which will help the muscles around the blood vessel relax and dilate. And as they dilate, blood pressure goes down, of course. However, the endothelium can become insulin resistant. And so now, even though insulin is attempting to create nitric oxide, it can't. And so nitric oxide levels stay lower than they should, and a blood vessel that should have been dilating stays constricted, and thus blood pressure stays higher. So there are distinct and myriad mechanisms whereby insulin resistance contributes to and is indeed the leading cause of insulin resistance.
Earlier, we were talking about fat burning. Can we discuss ketosis, fat burning, and your research paper into genes for Alzheimer's that you released a couple of months ago?
Oh, I'd be happy to highlight that. I was very pleased with that work. So ketones are very misunderstood. They're one of the villains of metabolism, and very wrongly vilified. I'm often within the kind of cultural realm of when I have opportunities to speak about these topics, even in classes. In fact, when I teach anything about ketogenesis and ketones, I'm always quick that people don't think I am intending to be an advocate of ketones or ketogenic diets, but I have no qualms being viewed as a defender. I believe ketones have been very, very misunderstood and maligned, and not without proper justification. So ketones are, in its simplest definition, products of fat burning. When the body is burning a very high level of fat, which the astute listener will remember can only happen when insulin is low, the body begins burning more fat than it needs. If insulin stays low for 12 plus hours, the body's fat burning it just keeps going. And even though the body has met all of its energetic needs, it can't stop burning fat. And this excess now, where we're burning more fat than we need, is this almost pressure release valve that's becoming the production of ketones. So ketones are products of fat burning very, very directly. It's just this byproduct of burning fat at a very, very high rate and for a relatively prolonged period. Now, that in and of itself is fine. So if someone's measuring their ketones in their breath or in their blood or in their urine, it simply means I'm burning fat right now. Now, classically, decades ago, ketones were considered metabolic garbage. It was just considered a waste product, not what I said, which is a byproduct, but indeed they would call it a waste product classically, in nutrient biochemistry, which is absolutely not true. Every cell in the body with mitochondria, which is almost every cell of the body, is capable of using ketones, and indeed will use the ketones very readily. For example, the brain. And this brings us to my study. This study that we did, that I'll elaborate more on in just a moment, was based from work of other labs, finding that in early stage Alzheimer's disease or outright Alzheimer's disease, the brain's ability to use glucose is significantly diminished. However, the brain's use of ketones is uncompromised. So if you look at a healthy brain or a brain with Alzheimer's disease, they will use the same amount of ketones, or indeed the Alzheimer's brain will use even more. So there's an enormous use of ketones, whereas there's a very compromised ability to use glucose. And that's the hybrid of the brain. The brain, whereas the rest of the body, the hybrid engine body-wide is more glucose and fat, that is not the case for the brain. The brain is a hybrid using glucose or ketones. Now, the particular tragedy is not only can the brain or the parts of the brain involved in memory and learning in the hippocampus does it need insulin for all of its glucose uptake? So as the brain becomes insulin resistant, it gets less glucose. But at the same time, if the body is insulin resistant, their insulin levels are going to be high, and now there's little to no ketones in the blood. And so the brain is starving, calling out for the glucose, which it could be in very high levels. I mean, ironically, Matthew, the body could be hyperglycemic, and yet the brain can't get it. It's this twisted version, this metabolic version of this old poem story, The Rime of the Ancient Mariner, where you have this sailor dying from dehydration, having been stranded, and he had water everywhere, but not a drop to drink. This is the brain saying glucose everywhere, but not a drop for me to use. I can't get it. Ketones become the life raft in this case. It becomes the fuel that the brain can use if the ketones are there. But again, the average person with insulin resistance not only has a brain that can't get glucose very well, but also is directly inhibiting the production of the only other nutrient the brain can use. Namely, it's the high insulin inhibiting the production of ketones, because insulin wants to stop fat burning from happening. Now, the results in my study were compelling because we actually provided some genetic explanation for the studies I just mentioned, the studies that actually measured the rate of glucose use and ketone use. We found that with Alzheimer's disease and insulin resistance of the hippocampus, there was a direct reduction in the expression of genes involved in encoding proteins that help the brain use glucose as a fuel. So all of these glucose metabolism genes were significantly down, whereas the ketone metabolism genes were almost, I say almost because there were a couple exceptions, were almost totally normal. And this was human brain samples post-mortem where people died with confirmed Alzheimer's disease. They absolutely had dementia, and people of the same age, race, sex, weight, etc., who died with no evidence of Alzheimer's disease, and their brains had normal, not only normal glucose gene expression, but normal ketone. So it was the ketone gene expression that was normal across both sets of brains, but it was the glucose gene metabolism expression that was affected in the Alzheimer's brains. So this is one of the instances, this is one of the disease states based on those findings and other findings where if a person has a neurological disorder, bipolar, anxiety, migraines, epilepsy, Alzheimer's disease, Parkinson's, I am an absolute unapologetic advocate of a ketogenic diet. That is an instance where you have a tissue that is directly benefiting from the ketones, which doesn't always happen, but it does in these cases. There is direct evidence to show that all of the pathologies I just mentioned and more benefit when ketones are higher in the blood. So of all the times, if anyone listening has any hint of cognitive decline or any hint of migraines from time to time, this is a person who very, very likely would benefit from a ketogenic diet.
That's fascinating. I must get the link to that particular study and pop it in the show notes for this episode. Ben, just one more question before I let you go, because I know you're very tight on time. You mentioned this in the book, but can we look at the 4 pillars of an insulin-friendly diet? What should people really be eating?
Yeah, great. Yeah, what a great way to end. I like ending on the good news, because a lot of the story that I tell with regards to insulin resistance, and I imagine a lot of the listeners hearing this, it's a little depressing. It's kind of a horror story. But if it is a horror story, it is one with a happy ending, because as much as there is a villain in the house, and now we know how it got there and all the damage it's doing, we can get it out. We can not only prevent the villain from coming in, namely insulin resistance, but we have a very effective way of shooing the villain out of the home. And that is these 4 pillars, which based on the 3 macronutrients and the timing of them all. So the first one, and I start with this because I do believe it's the most impactful, control carbohydrates. If a person who's listening to this is worried about their insulin resistance, just limit the carbohydrates you eat to whole fruits and vegetables. Don't drink them. And be very, very careful with any other carbohydrates. Keep them at a minimum. And there's no even, at least as a first step, you don't even need to count how much you're eating. Just fruits and vegetables, whole fruits, whole fruits and vegetables, eat them, don't drink them. And then second and third typically go together, which is prioritize protein. Make sure you're getting high quality protein. And generally that means from animal sources. That is a superior protein for humans. And then second, don't fear fat. And I put those 2 together because in nature, if you're prioritizing protein, you will always have fat that comes with it. There is no exception to this. There is no exception of an animal fat that doesn't come with, an animal protein that lacks fat. They always come together. That's how we should eat it. When fat is consumed with protein, we digest it better, and it ends up being more anabolic. It's easier on our guts. We'll feel a little better. Those 2 should come together. So again, prioritize protein and don't fear fat. And then lastly, frequently fast. This is helping us break this incessant, nonstop eating at every waking moment, where we're eating from the very moment we wake up until the moment we go to bed with our evening snack. We should, at a minimum, be doing mini fasts, which is pitiful that we'd even need to say that, just 4 hours between meals. And I would say a minimum of 12 hours from dinner to breakfast the next day. So 4-4-12 at a minimum. And then from time to time, as a person gets more adapted to using fat for fuel and they become more insulin sensitive, perhaps you can fast through breakfast and not have any calories through breakfast. Maybe drink some tea or coffee or whatever the person's habit would have them do. And then have a very big lunch and taper off for dinner while still trying to keep those first 3 rules: control carbs, prioritize protein, and don't fear fat. And then eventually, perhaps the person is ready for a once weekly 24-hour fast, where maybe every Monday from Sunday dinner to Monday dinner, they have a full fast where they're just drinking, staying hydrated with electrolytes perhaps, but not drinking or eating any other calories, to just really help insulin come down. And the longer insulin is down, the more insulin sensitive the body becomes, and then the lower risk or the overall resolution of so many of these chronic diseases that we've discussed.
So many insights, so much knowledge, all backed by science. Dr. Ben Bikman's book is called Why We Get Sick, and I'll put a link to that in the show notes for this episode. Ben, thank you so much for your time. Really, really appreciate it.
Oh, my pleasure.